Great. All right, everyone, thank you. Welcome to Braid Meeting 62. So we've got quite a full agenda today, actually. We've got, we're gonna keep things on time, and I have a little redesign for the Braid homepage that I'm gonna talk about, just in progress, showing the status update. We also have a status update for implementing portals in Sync 9. And this is a technology in a CRDT or OT that gives you moves, copies, wraps, and unwraps within a tree. Also cherry picks. So we're going to talk about some progress in making that work. Matt has an interesting topic about generic mutations driven by a DAG. I think this is a way of looking at CRDTs. I glanced at it quickly, and has some interesting questions about how or whether we can prune history using antimatter or some other algorithm. Jonathan's been working on schema change, and in particular is putting together a nice challenge problem paper of the problems that people face with schema change. And we'll have some discussion about the problems, I guess the challenges that we face, and how well this is covering the space. Jay has a quick little update on DNS, or a quick discussion of it entitled "Is DNS Backwards?" And Austin Wright is joining us. Austin's been participating in the IETF and has a draft changing the HTTP patch method. And at the end, this is going to be his first time at the Braid meeting, and he said he might have some questions at the end. So that's going to be our agenda, but we'll just start with a little go around of how everybody's doing. And I guess so. DWeb is coming up in, I guess, 9 days now. So I think a bunch of us are going to be heading there. And this is partially where I'm been looking at our homepage and wanted to make something that's more easier for people to join and where our work is easier to see, so that we can have a bit more community awareness. And also trying to get some work together, still working on the time machines paper, but had a bunch of discoveries with Greg on the portals the last couple of weeks. And so been going a bit intense with that. But things are good. I mean, a lot of work's happening, so I'm happy, but feeling really busy. And how are you guys doing?
Very well. I'll go ahead and go. So I am also getting ready for DWeb Camp, and I have 2 sessions scheduled, but one of which I'd like to talk about a little bit today, which is DNS Backward. And so that'll be on Thursday afternoon. But this is a continuation of a session that I did in November, which was titled Viable Decentralized Identity. And I've put some basically code together and other things, and I'm interested in showing that in some detail to some of you, some of the participants from Braid that are going to DWeb Camp. So that's what I'm up to.
Well, I guess I'll go. Yeah, I'm going to DWeb Camp, giving a presentation, so getting that ready. And also looking into incremental view maintenance. So it's kind of far afield from CRDTs, but there's a use case where somebody wanted to write every state change, keystroke, mouse movement to the database, and then have their UI refresh from the database. And doing that at 60 frames per second requires some sort of incremental view maintenance.
I think so. You're saying you've got a view UI, and if you have an incremental change to the data, how do you map that up to an incremental change in the UI instead of re-rendering everything from scratch?
Yeah, exactly. Yep.
Cool. Great. Yeah, that's super interesting. I'm into that too. Cool. Greg, Jonathan, or Austin, you want to just?
How about I jump in? Yeah, hi, I'm Austin Wright. I'm going to DWeb Camp. I think I heard about Braid maybe a few years ago. Someone posted an email on one of the IETF mailing lists, and I responded to it. I'm active in working on JSON schema, and I was at the last IETF meeting pitching byte-range patch, which just fills in a neat little hole of I want to overwrite just these bytes in a file. Very simple, which is something that surprisingly does not exist. So yeah, and there's some ideas I'm working on that are sort of in this space, and Jay actually referred me here and he said you should join this meeting and join this call. So there's a few ideas I want to bounce off, and I think there's a lot of good ideas here.
That's exciting. Yeah, I already have ideas about how I'm going to work your thoughts into what I'm going to present later. So I think we're going to get a lot of connection.
I can go. I was a little distracted in this beginning here. Mike mentioned working on some portal things, and he wanted to demo a portal thing, which was mostly working, but had a little bug that I was fixing here, and I believe it is fixed. We'll see in the demo soon.
Sure. I've been working on this paper, which Michael mentioned, and continuing to push on my own solution to this problem.
Great. Well, thanks for the update, guys. So I think we can go ahead and get started now. So it's let's see, we're 11 minutes in. I'm just going to keep track of time. So let's finish this next one. Looks like 45. Okay, so at 6 p.m. we're going to switch to Matt. Or you don't know what 6 p.m. is, maybe in 50 minutes we'll switch. Okay, so let's go ahead and start on our agenda items then. So okay, first thing is working on we've very slowly over the past couple of years we've been doing some incremental work on redesigning the Braid homepage and taking a few more steps here. So this is the general idea. Just have some sketches. I think a big issue with our page, as you can see it right now, we're still just talking about synchronization for HTTP, but the group is actually doing a lot more than that now. We're also doing a lot of algorithms research. And I think generally, like, we have standards is one of our topics, but we're also working on algorithms, also building libraries, and we're also building applications. And over the course of the last, 2 years now, we've built up a lot of work in all of these meetings, but it's really hard to see the work inside of it. You have to know which meeting to go into and then know which video to click in and where in the video to click into there. So I want to make this work more visible. And so here's the first idea is we can do something that's kind of got crowdsourced ranking. So first I want to update the title, something like Working Group for Distributed State is roughly what I'm thinking here. And a little subtitle is we're going to make it easy to read and write any state anywhere on the network as easily as a local variable. Just kind of like a concept that we settled on, I think, or everyone seemed to click with, I think it was last summer or something. Show some of the different areas we're working, which is standards, algorithms, applications, and libraries. And I want to put all of our meetings into a database so that we're not manually editing the page each time. And also when the next meeting is, there's a little button for it, and just say we meet every 2 weeks. You can come to these meetings and go to other places that you can participate. But then down beneath this, I want to have some news items. And so this is going to be like all of our work items. And the idea is that we'll have, so let's say like here's the stuff we've done and organized by algorithms, applications, standards, and libraries. Each of these is an item with like a title. And on the right is a slider where you can rank the, and this is, you can rank stuff. This is with this, is that, sure, yeah. So we've got this, I want to try to use this, is that the right, oh, okay. And then you can also click on, here we go. So this is peerreview.org. This is a site that's using a protocol for like ranking things. This is the braid page. You can see my view of it. We can also see other people's view of this ranking, and things will resort differently depending on, oh, this was switched away from braid too, but let's try going back to the homepage again. So this is like Hacker News or Reddit, it's a list of links. Each one, you can rank them up and down on a slider. And then you also notice the different people here have different sizes, and you can rank them here. So I can rank Wrath down, and that will resort everything because his weights just change. And so this way, every user can have a different view of the sorted stuff. And imagine what we would do for the braid homepage. So well, I worked with Wrath last week to pull that data from peer review, from the braid section of peer review, into the braid.org site. And this is just a first draft prototype of it. This is a read only, but it's grabbing all of those items and showing all of the votes and the rankings on it. And so the idea is that we could all have some weight, and we'll weight up each other, or weight, if you want to bring someone new into the community, you can drag them up and give them some weight. And we're all just voting on stuff that we think is cool and think is well represented or representative of our work. And that way there's no single person deciding what all is going to be on the homepage. And you'll also be able to post this anywhere, since it's all be on the braid protocol. So you can post this on your personal blog. It'll just be like a little JSON array. Like basically you can post a feed of all of your stuff, just a JSON array of links. And then on the Puri site, those links can show up here and you can vote on them, because they'll all just like be feeding in. I just want everything to be feeding in from wherever you post it through here and then onto here, which will be somewhere, which will be on the braid homepage. So trying to put this together, we made a little bit of progress on it. And another thing I want to have is for the meetings. On the meetings page, I want to have a little widget here, like on YouTube, where you can give timestamps in the meetings and say what the different sections are, and then we can vote those up as well. So that if you come to a braid meeting and you participate in a great discussion and everyone loves it, then boom, it appears on the homepage. And we can make things easier to find. Or you can click into the algorithms and see just all of our algorithms. Maybe they have some tags. Here's all the recent stuff, and here's the all-time best stuff. So that's my rough plan. Any questions, comments about it?
No, I think it's awesome. Like, people need to be able to see the work, and it needs sort of like a pyramid, I guess, like a catch. And then you want to get more detailed, there's another level. And then if you really want to get super detailed, yeah, you can go to the videos. But yeah, this breaks it down for people.
Looks good. It looks, I'd go on it just to move people around and slide them around. It's like a game.
Yeah, like a little dance,
Except for
like
the,
slide to the left. All right, go ahead.
Except for you got these fancy widgets like the peer review and the meeting schedule thing, but the skeleton of it, looks like Notion kind of. You could probably mock it up pretty quickly in Notion.
Yeah, I think you're right. And we also have, this is some of our drafts from last fall too. We have a couple mock-ups of like roughly what some things could look like. But we just gotta put it together. So okay. On the next topic then, try to go through. I wrote 15 minutes, but that was pretty quick. Okay, cool. So now we have some more time. I'm going to make some more time for everyone else. So next up, we have this thing called portals. So let's check this out. Is the page going to load? Here we go. So this is kind of a work in progress. And so like I'm putting together a whole page with the description. We've got some code working. It's not fully complete at this point. So I think we're going to have to do another talk, but I want to, so I kind of want to take this as an opportunity to just like talk things through and get some live audience feedback. So if you guys have questions or things come up in your mind, that'd be really helpful because we can fold it in. This is a way, so portals is a way to represent move, copy, and wrap operations. And they can do other stuff too. we have this, like in the high level, we've been interested in trying to finding a common synchronization protocol where any CRDP or OT algorithm can use the same protocol. And that way we can make it much easier to have interoperability. And these algorithms are really complex and it's hard to find a common protocol, but it's a fascinating problem to try to tackle. And we seem to be making some progress. And one key part of a synchronization protocol is the patch format that represents change. And there are a bunch of different types of changes that you can make to data and ways of thinking about those changes. The most common ones for text editing is insertion and deletion. But turns out that you can represent any insert or delete with a single operation, just the replace. And here's some visual of it. So if you just replace like you can replace some region of a string with another string, or you can replace an object in JSON or some hash with some other value. And in the same concept, you can do an insertion, which is replacing nothing with something, or deletion is replacing something with nothing. And so just the concept of a replace can handle insertion and deletion. And we do have a spec for this called range patch so here's a spec for a standard way to handle a replacement in HTTP that maps into HTTP's concept of a range unit and a range request. And so with HTTP range requests, you can already describe a piece of a resource, and you use that like to resume a download. You say, I just want to download, get the last part of this. It doesn't have a way to put a range of a resource or a range if you want to put a patch into that. And I think that's what Austin has been looking into with putting a byte range. Is that correct?
Yeah. The byte range I'm proposing is limited into just overwriting data or appending data, or maybe truncating the document as well. I ruled out the ability to say we're going to splice in bytes like that. But another thing I am considering or might ask about is there's another specification called VCDiff, which is an early IRFC. It's like in the 3000s. It doesn't have a media type registration, but otherwise it actually does a lot of these. You can go through a document and you can, it's a very easy way to express a diff between two documents that might vary in size and the positions of the bytes. Like you can specify a diff between two tarballs as a very compact document. You can apply that patch to it. So VCDiff might be able to do a lot of this, something to look into.
That's super cool. Great. So this is kind of like context where this portal's work is that in HTTP, as we're looking for common protocols for reading and writing ranges, and HTTP also has the concept of a range, and they have these thing called a range unit. And so you can describe your range in bytes. That's what the bytes range unit does. Or if you have something like JSON, you could say, I want the JSON. And then instead of saying a range like this, you would say like the range of like .A, .B, bracket, array element 5 or something. And so you can come up with your own descriptors of how ranges or regions of your document are laid out. What are the addressable subsets? And then any of those things you can then issue a replace, or in our case, do a splice. So, okay, so, and feel free to just jump in and talk over me. I won't be offended. It's a challenge in Zoom sometimes. Okay, so this is a nice, like, you can do a whole lot with a range patch. But the question comes up, well, are there things that you cannot do? What else might you want? And one thing that you can't do is a move or a copy operation. So here's an example. So this is in this example, Alice and Bob are simultaneously editing this text. Alice wants to fix the spelling of her name. And simultaneously, Bob wants to move this hi Alice to the end of the sentence. And so here Alice is editing her name. She gets rid of the SS and replaces it with CE. And then Bob is trying to move hi Alice to the end, and he does that by deleting it from the front and then inserting it into the back. And unfortunately, these things don't merge very well. In most collaborative text editors, you'll end up with the CE appearing at the front, and then the misspelled Alice is appearing at the end if they happen at the same time. If we can express a move operation, though, then Bob, instead of deleting and inserting it, expresses this region has just moved over here. And then when we merge them together, the algorithm can just take Alice's edits and merge them over. So that's what we want to accomplish. And we can do this with this concept of a portal. And the portal is a general concept, just like the replace operation can generalize to insertion and deletion and other operations. Replace, a portal can generalize to move, copy, wrap, and cherry pick, and some other crazy things that I'll throw towards the end. And so I guess, so we'll just look at this. So let's look at what a portal is here. So this is a way that we've been, this is a way you can specify a replace, is you specify on the version of it, and on the left-hand side is the region that you're replacing. On the right-hand side is the contents that you're replacing it with. So this says replace the zero length region from position 0 to position 0 with the string hi world. And so this is just inserting the string at position 0. And the second operation is going to say at position 3, from 3 to 3, you're going to insert a portal to the region of 0 to 3 at the last version 0. And what was here was the characters hi with the space. And so what this is doing is inserting a portal to these 3 characters at the position right before world, and you end up with hi world. And so what you've done here is you've copied hi right after itself. And so that's the semantics of a portal. It's like a tube in the braid of space-time. All of these gray regions are essentially portals. And although the colored regions here are edits. So this is inserting A, inserting B, and then you can, this is just a way of looking at merging. And you can think of them, I'm going to go through this thing first. So you can think of portals implicitly every time in the unchanged region around every edit. So if we insert hi at the beginning of the string here, then the part that's going from world to world, you could think of that as a portal. That's just like the identity, the implicit portal. And that means that these 2 expressions are equivalent. The one where all you say is that I inserted hi, because I assume that everything else is the same. But this is equivalent to saying that the entire string got replaced with an insertion of hi followed by a portal to the rest of the string. So that's a general concept of a portal. And you can think of them as implicitly existing with every edit. But if you create them explicitly, you can do some cool things, like you can copy and you can move stuff. And this is like, okay, the last version from 3 to 7 now goes at the front, and the last version from 0 to 3 goes at the end. And so that's going to swap the order of the beginning and the end. You can also wrap.
My quick question.
Yeah.
So does this achieve the goal of me inserting something in that region before you copy, and then independently you copying that, and my insertion, when the changes are merged, my insertion now appears in the new position? So you have hi world, I insert something between H and I, and at the same time you're moving hi somewhere else. And when these changes emerge together, are you moving also the text that I inserted, or will my text appear in the original location of hi?
It's a good question. It's probably time for us to get a demo to find out. Let's try. So here's a demo. Greg's been building this. So we've got hi world. Now let's propagate those edits Let's hope it doesn't crash. Okay, so now I think what you're saying is one of the users is going to insert something between H and I, and the other one is going to copy it.
Yes, copy or move somewhere else. Exactly.
Okay, yeah. So let's go ahead and let's insert like a dot here,
Okay.
and then let's copy this high over to here,
Uh-huh.
and now let's merge these two together. And oh, that didn't seem to work. Hey, Greg, was that supposed? Is this a bug or is this?
Could you do that? It's not what I expected. I expected the dot to go into both places.
Okay. Okay, so we expect the dot to go into both places. Does that answer your question, Paul?
Yes, it does. Thank you. And same with move, I presume, right?
Yes, same with move. The dot would appear into the moved location.
Exactly. Okay, cool. Thank you.
Yeah, let's just try this. Let's see what happens here. Try high. Now let's I'm just gonna type a U over here, and now let's copy the high. Let's paste it. Okay, so with that time it worked. We got hui, and now that U insertion has propagated back.
Correct. Okay, that's what I would.
Okay. So that's what we're going for. And you can see here in this data structure, so this is showing the final rendering of the text. And then this version is outlining all of the portals. And so this hui is present because it is a portal into this hui. And then down below, this is showing the data of the portal. This is saying that this is a portal to the region from 0 to 2 at version 2. And so we can also probably, let's copy just the H here, and then, oh, that's not even happening. Okay, we got some more bugs.
Oh, one thing that definitely, you can't put something at the end there. You can't draw onto a portal. It doesn't, the code isn't written to sort of take things back in from the rendered text to figure out where in the data structure to put it. But if you type at the beginning where the things are normal, you might say, then you can insert stuff there.
Got it. Okay. Okay, great. So I inserted something at the beginning. And so now we've inserted a portal just for the first character of the H. And this is position 0 to 1 at version 3. Now we're at version, looks like 8. And so position from 0 to 1 at version 8 is no longer the H, or it is now an H again. Anyway, that's our demo. We're working on it. It's still a bit buggy, but we've got some of the basic mechanics working.
Yeah, and those version numbers, I guess, are local to the client. Then once they merge, I mean, you don't have like an authoritative linearized version, or do you? It's like every client's gonna have their own version of the doc, but when you merge, it produces a new version, I guess.
No, it's deceptive there because it says V, but the other side creates versions.
The other side is X.
They should say like A and B would be more clear.
Gotcha.
V makes it sound like it's the only version number, but really it's a peer identifier.
Okay, so when they merge, it says, oh, you had a portal to X, your peer identifier, sequence number, whatever. I guess it goes and looks up what the state was at that.
Are you familiar with auto merge or YJS or?
Familiar with YJS, yeah.
Okay, this is using a data structure kind of like YJS that's quite powerful. Like this demo, we were trying to add portals into this thing, but the data structure that it's using, it has a huge amount of, like it's 1,000 lines of code, and it knows. It's able to figure out based on a version ID which parts of the data structure are visible.
Gotcha.
Based on the so-called time DAG, which amounts to every version says which versions were parents of it, and it can traverse that. It's not showing that here visually to you, but under the hood.
Yeah, and I'll show that soon. Actually, there's going to be this little visualization of it, which isn't playing. So controls play.
So I think so this is like new. Okay, so the ability to do things like move and copy and wrap haven't been demonstrated in any CRDT, as far as I know currently.
There is
And
moves.
those are the reasons. Yeah, well, that you're talking about Kleppmann's move, that is like really hinky. It's not clear that that's actually a useful implementation, but
Okay.
it's very limited. It's not a general purpose kind of move at all. These are my opinion. But and it doesn't generalize to handle all these things like you're handling. So this is like important, I think, and this is actually, these are the reasons that I have built my system, which is not a CRDT, which really harks back to OT, because I couldn't figure out any other way to do these things. So I think, you really should communicate this, right? Because this could be a novel idea here. I think it is a new solution, and I think you should extract this out from braid and like say, here is a CRDT or OT, because I'm not really clear what's going on underneath. It sounds like you're building this on top of a CRDT, the CRDT from, is it YJS or?
Yeah, we're building on Sync 9.
Which is
Yeah.
what? Is that a CRDT?
Yes, it's a CRDT. Greg built it, when I was collaborated with him on it.
Okay.
And
because
this is a
when you were first describing this, you were just using like, integer indexes to describe these operations, and CRDTs don't generally do that, right? They have these really fancy schemes for
Right.
IDs and so forth, and dense, orderings and so forth. So, when you describe it as based on integer offsets, it sounds like you're doing an OT kind of thing, because that's how that world works.
Yeah, it's a
So
good point.
it's unclear to me from this presentation whether what you're talking about here is an OT or a CRDT, and what kind of CRDT. So I think it would be really, really powerful and useful to extract out this portal idea and define it standalone as, what is this, a CRDT, an OT? Just define it on its own instead of, in relation to all these other things. And the thing, your contribution here is these high level things like move and wrap and copy, which really haven't been done in any general fashion yet in either OT or CRDT. And that's what I'm doing also. But this approach you're taking, I didn't really think of this. And, you may be doing it quite different from me. So, they might end up being equivalent. I don't know, but I think this is interesting, and you should think about this as a separate thing that you've invented and you want to write it up for the world.
Thanks a lot. Yeah, definitely going for that. And I think part of the confusion here might be like, we haven't gotten to the implementation section. Yeah, and there's actually are two separate things here, because there's a language of expressing change, which is just a path format. But then in order to get an implementation, you also need to define how things merge. And there are a bunch of options for how things merge. And so it's kind of got like these three sections. There's a language for change. We've got some options for how to merge things. Also, if you merge them well, you can support rich text edits, like few simultaneous boldings of something, which I could get into. And then we've got an implementation here that we're building, where we're making some merge decisions and plugging it into an existing CRDT. So maybe let's ground us in the CRDT itself a little bit. And so let's put this to, here we go. Okay, so this is an boom. Okay, great. So I just froze some CRDT edits. Currently the text says shell IC patch freezo, and this is the Sync 9 data structure that represents those edits in the fancy time collapse version, the fancy CRDT thing. And so we see the string shell IC, and this is read off in that for search order. So you read shell IC patch space, FREZO, so Frezo, and then we have some deleted text, deleted wink. And that's how you read this. And you can also just read it from left to right. And so this CRDT data structure supports strings, as you see here, but you can also support other data types. This can also, this data structure also works for JSON, although we don't have a visualization for it. But you can also, so it supports arrays, strings, booleans, numbers, maps, and it has a mapping to that braid data structure as well. Like this is just a different language for the same data. As well, this plus time, if you have a time DAG and you have the time DAG plus a space DAG is equivalent to the braid data. So in a sense, the way we think about this is that this is the network data. This communicates all the changes. Each peer then receives it and looks at the time and then computes this space, this CRDT time collapse of space. And so in order to implement this, there are 2 steps to modify Sync9 to add support for portals, which turned out to be very simple. And we were like really stoked by it, which is why we started programming it this week. And so we just add a new primitive data type instead of sequences, maps, and primitives, I guess, or atoms, maybe this would be called an atom. Then we also add a portal data type. And there are 2 ways to store the portal. We're storing it here using a start position and an end position at a version. And that's what you were referring to, Jonathan, as the OT style. But it's equivalently, you could also just store this with a start like ID and an end ID using the internal time collapse data structure. Both of those are equivalent. You just need to know which location this is a portal to, location in spacetime or the collapsed version of spacetime.
So when you do a start index, end indexed, you would have to essentially get a snapshot of what the document looks like at that version, so you can figure out what characters are between that start and end index.
Exactly, yeah, and that's what this is trying to show. That so Sync9 gives you the ability to rewind in time, and you can see the space down below. You can see which edits are appearing and disappearing, and that allows you to see exactly what it looked like at any point in time and reconstruct it, and then we know what positions things are at. And the way that the Sync9 does this is it just retraverses the entire data structure, throwing out the edits that didn't exist at that time. And so it's O of n, and that was fine for us because we are pruning all the history so that n stays small. So we just use this very simple algorithm and add complexities to prune the history. But you can also make this more efficient using shared history range trees or things like Steph's developed a lot of range tree algorithms, and you can have a range tree for every version that will give you log n. In log n time, you can do that mapping. And so there's you need this data. You need to be able to go back in time to figure out where things are when you read the CRDT. So CRDTs have a read function which prints out the current version from that time collapse. And we have to now modify that read function so that whenever it encounters a portal, it will recurse into it and print out whatever's there. And so our read function I'm pretty sure that it calls itself again, but with some new parameters, because you want to tell it to find that start and end position at the version that the portal was at. But once you get there, print out all of the new stuff that has happened within that range since the portal was created, or whatever gets merged into there. And I'll fix that.
Before the portal was created, all the concurrent stuff.
Oh yeah, yeah. What I said was slightly misspeaking.
All right.
And we want, so there is the original thing that we did was to print out all of the stuff that has occurred in that region. But we realized that the semantics of this are a bit tricky and can get a little bit crazy, because essentially what you end up with then is any place where there is a portal becomes like, if I were to type right here, it would duplicate those edits to everywhere else that portaled into it forever. And you just have this like really reactively live editing text area. And there are some cool situations where you want that. And I can show some of these. Like there's some crazy features you can build. Like Jonathan, I got your subtext linked in here. I've got my linked editing thing. Maybe I'll just show this demo. So this is a programming editor that lets you simultaneously edit copied and pasted code. So these are two functions. They are the same thing, except this one has an if statement where this one has a while. Otherwise, they're the same function. And so you can, in this editor, you can select them both as two selections. Then you say link them. It does a diff. It shows you which reasons are the same and different, and it gives you simultaneous cursors so that you can edit them both at the same time. And you can implement this using portal semantics. And you could also go to one of them and add a patch just to that one. So we're going to turn off linked editing and now make this one just say wake all because it's different, and add in that difference. And there are a lot of situations in which it can be really powerful to be able to simultaneously edit things, have them be linked together, but also with some persistent differences. However, you really want a fancy user interface to do that. So portals need to have, and this is why we have this section here, that portals need to have some temporal scope. So when you have portals that last for a long time, you can get lots of crazy features, but there is a basic form of the portal that just gives you some of the semantics you need for copying, moving, or wrapping. And you can think of this, so this is only going to copy edits that happen in parallel with your creation of the portal when merging things together. So if Alice and Bob are editing and Alice copies some text while Bob is editing the text, when they merge, you want the portal to be active. But now that they've merged, let's make everything die down and become dumb so that it's just regular text. And that way, there's no time in that you're going to type something and have it magically duplicate to other places in your document. The only times where, if you are going to have a situation where you're typing something and it's magically duplicating, you're going to want to have some special user interface for that. But if all you're doing is cut, copy, and paste, then you want to have this rule where the portal is only active for merges that are happening in parallel.
So Michael, when you described the portal, it was pinned to a version. The source was pinned, and now I think what you're saying in persistent is that it's not pinned anymore. Is that it's floating into the current date.
The portal is pinned at a version, but the idea of the portal is that it's going to show you all of the edits that have descended from that version. So like the portal is at that version, but when you peer into the portal, you're seeing everything that's come from it. And but you want to have some scope at which point you don't see stuff after that point anymore. I'm going to make some better diagrams for this. It's interesting. This is a part of the write-up that I didn't feel like I explained very well, and I want to do it again later.
Right.
But there's this interesting thing where you don't want the portal to be active for any versions that the portal itself is an ancestor of. So if you can see the portal in your history, then you don't want that portal to be active anymore, in a sense.
Okay. So this is significantly fancier now when you in this persistent thing, which is nice if you can do those fancy things, but it's certainly got to complicate things quite a bit as well.
Exactly.
So you might want to think of this as two levels that, say here's beginning portals and here's like Star Trek portals, right?
Exactly.
And Newtonian portals and post-Einsteinian portals. But
I like that. Newtonian, post-Einstein. That's a good way to put it. Yeah, because you've got the crazy wacky ones that are like interesting, but know that you're walking into a wormhole when you do that.
So you know who else has portals? A similar idea is Boxer. The Boxer language, Andy DeCessa in the 90s built this cute little kind of materialized Lisp with everything as boxes. And he has portals with and uses them to do all kinds of fancy things. It's not well documented though, but I know the
Great.
people that are working on it and they'd be happy to explain it to you.
Great. Great.
But you could have like recursive portals, you know, so you can get an infinite regress, you can, you know, things like that.
Exactly. Yeah. And that's something that the basic portals, this simple rule of ruling out descendants means that you cannot create portals to the future and you can't create circular portals. And so it kind of rules out all of the crazy stuff. And so it's just kind of Newtonian, like you said. Yeah, Greg?
Yeah.
I just wanted to throw in that although the persistent portals seem crazier from a space-time perspective, implementation-wise, they were what I did first, and they were the easier thing. And I had to like trim them down because they just go infinitely. That's an easier thing to express than that they stop in some, you know, on some threshold.
Interesting. Yeah, you know, I got to say this again. You need to define this. It's not just the secret sauce you've got inside this big thing you've built. You need to extract this out so that other people can understand this idea. You know, just do it in terms of a list CRDT, right? Just a straight list CRDT. What does it take to add portals to a conventional list CRDT? You know, minimal thing there. Basic portals and then advanced portals, and I think that'd be very interesting. I think it's novel. It's an invention.
Thanks, Jonathan. Yeah, I really feel that. Okay, well, I think that's about that. There was one more little trick here. So basically, this temporal scope that we're talking about for the basic portal. There's another issue with move, and that is when maybe I can even show it right here. Yeah, so if you type my in here, let's say that we move this region over to the end of the string, then normally let's say so we move the region while somebody types the my. So that means that you've got a conflict because on the you know, Alice deleted it, or you could think of it as deleting it and then pasting it somewhere else, but moving it, and then Bob edited it, so you've got a conflict. Normally in collaborative text editing, when we get a conflict, the way we resolve it is we insert everything inserted and delete everything deleted by both parties. And so what happens here if we follow those same traditional rules? Well, Alice deleted the hello, and so we're going to delete this everything here. Bob inserted my, and so we're going to insert my. But and then in the portal over here, we're going to have a portal here that's going to have the hello because it wasn't, you know, it was portaled before it was deleted. And then it's also going to portal the my. And so we're going to have the portal for hello and my. But the problem is that the my is still going to appear in the left part because of the traditional CRDT collaborative text editing rule of inserting everything inserted when there's a conflict. So we actually have to make another change to our CRDT to not show the my. And it has to know that this was not just deleted and then portaled, but it was moved in a sense. And we haven't implemented this yet, but I think the way that there's just a simple rule to follow, which is if you have, let me see how I described it. If branch A deletes and portals a region while B edits it, then you do not display B's edits in the original region. And so that's a place where you also scope back time and we would hide the my. So we'd have an additional little rule in knowing what to traverse for the original region when things are deleted and portaled together. But
and how do you know they're portaling it? You're just hooking into the fact that they pasted, and a paste is a portal event?
Yes. Yeah.
And if they paste
And
many times, it's just many portals.
Yes, and so you can paste many times and have many portals, and the my will appear in all of those portals, but you don't want it to appear in the original region because it's been moved or copied. So that's just a taste, basically, of like where we're at in this work in progress. And that's it. I'm going to try to, we're going to work on this, try to make it better. And as Jonathan's advocating for, get it more crystallized down into something easier to share, more general to understand.
And would this tie all the way back to your first range patch example, where like your range patch could include a version, so that way you can, I guess, submit range patches over HTTP and correctly merge them?
Totally, yeah, and that works right now. Any range patch can have a version. I don't think we have examples here with versions, but but that's because the patch format doesn't contain the version is outside of it.
Okay. So in some other header or something.
Exactly. Yeah.
Cool.
Mike, just to confirm, but the range patch allows you to specify the insertion operation, but it does not really encapsulate the move operation, right? It requires something else on top of that to express that.
Exactly. Yeah. So in order to express a move, you would use a range patch to say, do we have an example here? Oh, I have an example here. Commented out. Here it is. Okay. I'll just uncomment this. Okay, so here's a move. So you have one range patch that says this is a.c.b is equal to a portal. So this is like a copy. So a move is where you copy it and then you delete it. We're going to delete the old thing and while copying it to a new location. And so this is two range patches expressed as a move. And the portal is in the right-hand side of one of the range patches. So portals just become values that you are patching into a range.
Okay, and are the portals two-way links? Does it matter which of the copies I'm modifying when the portal is created?
Yes, it does matter. They are one-way links. And yeah, if you want to have something that is symmetric in like advanced portals, then the way to do that is to make two portals that point to a single place in space-time. And then you make all of your edits to that single place in space-time.
No, I think it does make sense, but it actually looks interesting because the portal preserves that information for the copy operation. So imagine you copied the fragment and then I got your changes. So I have high world, where a high is the portal, second high is a portal into the first one. So now if I am modifying the first high, does this mean that my text will be duplicated as well?
Okay, so we have, I think this example here, we have high world and then we made it high world.
Exactly.
And now you're asking, if you now modify this first part,
yes.
This is where we don't want those modifications to propagate here by following the rule that portals have a temporal scope. And if you have seen the portal, then your edits do not propagate.
Okay, perfect. That's what I would expect. Okay, I got it. If I have not seen them, then they will. But if I have seen the portal and we synchronize, then essentially it is cut. So there's no portal anymore. Okay, that makes sense.
Exactly. Yeah, and that's for the basic semantics.
But I'm curious what kind of modifications it requires at the protocol level to actually send those changes back and forth, and would there be alternatives in terms of the protocol? So you're talking about one way to do it, to send with that patch specification, but I can envision some other ways to send that same information, right?
Yeah, there are different equivalent ways to send the information, and the way that we're doing it here is very simple. The patch doesn't have to know about it, just the contents of the patch has to allow for a new data type, which is a portal. And that's all that you need to specify in the protocol.
Okay. Interesting. Thank you.
Yeah. Austin, I think you had a question or something.
Yeah, maybe a comment. I was thinking about how does this generalize to things, or more specifically, I was reminded about a colleague showed me a project he was working on, something similar for like digital audio workstations, because those tend to have very repetitive portions where you want to repeat a melody, but maybe you want that note to be different just for that one bar or something.
Yeah.
And he was working on a research project, like dissertation, on actually describing this mathematically in such a way that you could actually predict what was going to happen in the future with some amount of certainty. And he was working on working this in the MIDI protocol somehow. I'm gonna have to pull that up because that seems related. Like he was looking for, okay, I just want to edit this note and have that propagate through all of the copies of that are in the rest of the document. And that seems like it would be, or that sort of, that seems like it would be a declaration at the media or at the document level, and not something that actually goes over the protocol as such. So maybe there's, I don't know, that text editor example made me think of that.
That's awesome.
Yeah.
That was my inspiration for that text editor demo. Originally, I wanted to do it for music, but I was at university and they wanted me to do it for programming. Yeah, that's super cool, man. I'm really excited to talk to you then. I'd love to see the dissertation too that you're referencing, because that's a keen
it was a
interest of mine.
long time ago, a few years ago. I think I downloaded it somewhere. I'll have to pull it up.
Okay, great. Cool. Well, we're also at time. So I guess that's it. Thanks a lot for your feedback. I'd be curious to hear any other thoughts or suggestions or questions for that. We're still working on it, and yeah, love to get your help. But now we've got Matt. Do you want to take over the screen? We can't hear you, Matt. You're muted.
Okay, you hear me now? Cool. Yeah, so I guess I'll start with a high level idea, which is like, if you're giving developers CRDTs to converge their state, then they kind of have to know what CRDTs to pick. So like, oh, this variable needs to be a counter. I need to choose a counter CRDT. This thing's a list. I need to choose a list CRDT. These things maybe they're last right wins. I need to choose last right wins CRDTs. So like, is there a way to just let the developer just write code, just write mutations, and then in the background, we understand when those mutations are run. We kind of create a time tag, I guess, for those mutations. So then we can apply them and get the correct semantics the developer expects. So in like this example here, you start with some initial state. The developer declares some mutations. Here, they're just taking that initial state in. Yeah.
Can you zoom a little bit?
Yeah.
Thanks.
They're taking that initial state in, they're incrementing a counter for their increment. So they're not doing anything special besides a regular increment. If we come down to this example, so I have 3 different nodes. I can increment the counter on node A, increment on node B. So I've done it 4 times here, done it 2 times here. I should sync and should get 6. And so I didn't have to like choose a special CRDT type or anything. The developer just wrote like, I want to increment my state. And sort of same for like add items. They're just pushing onto the end of an array in their mutation definition. We can go to a bunch of all the different nodes, add items. And then when we sync, the array is converged and unioned across all of them. So what's going on in the background is essentially it's creating a DAG where every node in the DAG, what's serialized is the event name and the arguments to the event. And then to recreate the state, we essentially do a walk of the DAG in order on every peer and replay all the mutations against the initial state. Obviously, you can get into weird cases. So like preserving user intent can become a problem. So like if the developer is naive and like delete item is just deleting at an index, you can get cases where like, say you want to delete index 2 on both nodes, or index 1 on both nodes, you sync and you end up removing 2 items. So like it doesn't, since you're, so I guess identity becomes an issue, right? So you can't, the developer has to still understand some things about CRDTs, right? If you're always removing at an index, when you merge, you know that index is unstable. Different items will be at that index after different merges. But I guess, I mean, that's not super important. What I was really curious about, I guess for the purposes of this meeting, was for this DAG that I'm essentially generating with these user-defined mutations. Would it be possible, so if I have a snapshot of the state at every version, is it possible to like apply antimatter to remove whole sections of this DAG and to just replay state from a given node, even though I've dropped history? And if I need to go more background and detail how this works, I can do that.
I think some background would be helpful. Yeah. So what I'm just to restate what I'm understanding here is that there's some part of this is naive to merging. Like you don't have to specify the CRDT, but then I saw where it is doing the merging. Like there's all these things behaving as counters, but I didn't see you ever say that they are counters. Is there a place where that gets defined that they are counters? And then the same thing with like these append only, I guess they're append only arrays or something?
Yeah, so what happens is this is just pure JavaScript code. So just regular JavaScript variables and just a regular JavaScript function. So just the user just said, I'm going to increment this variable and didn't have to declare anything to the framework. What we do is essentially we create a log of every event that's ever happened and we just replay it in order. And it just so happens that that makes counters work, it makes arrays work, and all these sorts of things. So like I could add a decrement.
How do you tell the difference between increment and assign?
So I'm agnostic. So I guess let me bring up a log of what this looks like.
Is the log replaying that actual code? Is it like you just type some code? Is it going to rerun that code?
Yeah,
Or,
exactly.
I see.
Let me. So,
Okay.
So yeah, every peer has a copy of all the code. And what's built every time you run a increment event or a decrement event. Well, anyway, every time you run an increment event or decrement event, it's just playing that mutation and it's creating a log entry that says this mutation was run called increment and this is the arguments that was given to it, in this case, nothing. And on every peer, they have the whole event log and they just run through the log, replaying all the code that they all have. So since everybody has the same code and that code needs to be deterministic, they'll all, because they all play the log in the same order, arrive at the same state.
Okay, and the DAG is giving you the same order. So when you have a DAG and it probably sorts them consistently, and then every peer is going to run through like in a DFS of that DAG.
Exactly.
Or something.
Yeah.
Okay, so it's going to like linearize the DAG.
Right.
I want to throw out, Matt, my initial impression is that, roughly speaking, yes, you can look at a part of that DAG and consolidate it. The only issue for you here is that it's going to, I'm not sure how you will consolidate it, because you need to somehow make some smaller thing that does all the same thing as running all those code. But there's no way that you can know it, that because they could be Turing complete.
Oh. But you can store the state.
Yeah, Joe, I just need the last. So I haven't read all of antimatter, but if like I bloop a section, don't I just need the state at that latest version?
Oh, that's a fair, yeah. I guess what you're saying is that all the future code will be run on that state. Yeah. If everything, I agree. I take back my objection.
Yeah, I have a better visual. This is not quite exactly the same concept, but it's close. So it's like a to-do list based on events. I'll say clean on this one. And essentially it shows you the event name, the arguments, and when you sync, right, it's creating that DAG, and it gets linearized by doing a specific traversal. But yeah, I think, so my thought was, if I'm getting snapshots of the actual application state for every node at a point in time in this DAG, maybe I could, start collapsing out sections. So that way I don't have to replay. Well, it's just I don't have to keep the whole DAG around.
Okay, this is really cool, man. I totally think like, yeah, the antimatter thing can help you. And also, what a cool construction. Like, it's such a practical way if you just want to get consistency and you don't really care too much about the merge semantics, because a lot of the time it doesn't really matter. And the way that developers write code today, they don't care. Like,
Right.
we have like inconsistent bad race conditions. Here, at least you get consistent race conditions. And yeah, it like requires no additional effort. And then, yeah, antimatter can clean up the DAG afterwards. This is really interesting. Very cool, practical use case.
Yeah, and I've started laying out, I tried to get into it before, I don't think I described it well, but like, if you're removing items from an array by index, you can get weird problems. So I guess you want things to, if you care about the merge semantics, I've started laying out, like, I'm calling them intent preserving principles, maybe it needs a better name, but like ways you write your code in these mutations so it does merge how you expect. But at this point I find out like, oh, it's kind of like reinventing RGA at this point, because for someone to say, oh, if you're like going to insert into an array, you need to say what you're inserting besides, you need the ID of the thing to your left or whatever. So I don't know. But yeah, it's cool. Let's get you off the ground running quick. But then once you want to do something complicated, maybe it's easier to go back to a CRDT that's like been developed. I don't know.
But doesn't this end up being all the problems of, concurrency, of uncontrolled concurrency, or, databases without any isolation, that, you just have people stepping on each other and it's effectively non-deterministic results based on whatever scheduling order these things happen to decide on.
Yeah, I mean, I would say it's just, I'd say it's like no worse than last right wins though, right? Because last right wins is kind of arbitrary right wins, where just a version is picked out of all the concurrent writes.
Yeah, kind of, I guess. Although there's ways that these can, I mean, last right wins, at least, you know what you're gonna get, whereas this is a piece of code that's going to rerun, and in general it might be reading state, right? It might have, into state that it's captured and things like that, so very hard to predict what it's going to do.
Yeah, so there's that one giant drawback of like these mutations would have to be deterministic. Like if every time you rerun somebody's mutation is producing a different result, then every time you retraverse the DAG, you're going to end up in some random state.
Right. But if you do follow the principle that your mutations only read from other state that's in the system, then you know that they are going to, it's safe to rerun them and they're going to run deterministically. And so you just kind of want to have all of your state captured. And another thing that you can do here, I'm just realizing, you can also have transactions, because you just run the entire transaction of many reads and many writes within that function. And then you'll know that it's executing atomically.
Yeah.
And that can give you, I mean, transactional guarantees are pretty nice. In that sense, this will behave similar to Paxos, which or Raft, which gives you linearizability. Like you have a whole bunch of replicas, it'll make sure that they are at least running all of the commands in the same order.
Yeah.
Right. Assuming transactions are atomic single function calls. If it's a series of calls spread over time, which is what they normally are, then then all bets are off.
Yeah, I guess you could encode it. Like maybe you could add a primitive where like, oh, I'm starting a transaction. So all the mutations run against state should be bundled up to a single node in the DAG.
Right.
Yeah, well, this is definitely super interesting. Yeah, and as for pruning, so one thing that antimatter does is it gives you the ability to prune things in the middle of the DAG, right? So like if, let's say that there's a disconnection event that happens, and now we only have 5 nodes remaining in the network, and they're all making mutations. We can prune all of those mutations within this click of 5. But we'll store this old history, and then once the old peer comes back online, then okay, now we can prune the rest of that. Now,
Okay, so it's not,
unclear to
if
me
you're
right now.
partitioned forever, you don't have to wait for everybody to come back.
Yeah, and that's, I'm not sure exactly how to do that where what we're doing is storing the last state. Maybe it's the same. Maybe just store the
right.
state. We store a few states.
Well, I guess I
was
don't
thinking the
think in
same
my
thought.
case.
I
Sorry,
think
what's
it
that?
is hard, as you say, Mike, if you just stir the state, if somebody else wants to run some other computation, is what you really need to know is what order all of those things would have re-executed in. And it could be that they all execute before this long thing runs, or it could be that they execute after, even if you know that it won't execute with them. It seems like you need to, if it executes before, then you need to know what its result was, and you need to run this computation on that result.
Yeah, that's right. If they're really old, you have to rerun everything.
Anyway, antimatter can, like, in a certain sense, what it does is it tells you, hey, everyone who was here to begin with, like everyone who's heard of this thing, they're here now, and they have heard of this new thing. So it kind of, like, for you, like, the thing that it can definitely do is just tell you where you have a, like, everybody convergence on a single version. Like, everybody, all future edits will be made
After that version.
after this version by everybody.
Yeah, that sounds
Yeah.
good. I guess the only problem is like, yeah, if somebody does go offline forever and they never come back, then I'm stuck.
Antimatter gets around that because it is, like, it knows more about the kind of inner workings of computation, you might say. It can trim down its.
Because I guess it knows about like the Sync9 algorithm, or is it?
Yeah, the
Taylor?
Sync9 algorithm is able to kind of turn itself down and collapse in certain ways that your computation won't be able to.
Right.
Well, maybe, I'm not sure there won't be, but here's a way of looking at, so, you know, we haven't implemented antimatter for non-Sync9s, but a way of looking at it is that there is a general part, which is this part of this network with the messages is general, and this time DAG is general. So if this stuff down here is, this is Sync9, and this is like range patches, which you're not going to have to care about. But on this part, basically, it'll tell you when, as soon as a version here turns gray, it'll tell it, then you know that everybody has seen it. And so it'll tell you when something's turned gray. And it'll also put these little dingly, these purple things are where there was a disconnect when that version was outstanding, I think. So basically it says like these things have to be pinned. And once we connect these guys back together, those purples will disappear. And, oh, interesting. So they were green. Well, anyway, so it'll tell you which things to get rid of.
Okay, so you couldn't, so things were gray, but because there were purple stuff, you couldn't remove the grays? Because now the grays are gone, I guess, after you relinked.
Yeah, that's right.
I'm confused about that too.
The purples were fissures. They were holding
right.
present, so that because somebody might use them as a parent, somebody who is not not part of our local network, somebody who is disconnected from our local group that might.
So,
gotcha.
And this is because Sync9 needs more information. Like just because everybody's seen something doesn't mean we can get rid of it. It needs to have a whole like bubble shape of things that everyone has seen, all of the versions at the bottom that and all mapped together. It needs a bit more for it to delete stuff in the past. And so you'll have to define what kind of past history you need as well. But my guess is that all you need is just the last state, because you don't have any merging and everything's very simple. Which means that you can probably prune more aggressively than we do. Like all of these versions have been seen, but we're keeping them around because they contain patches down here that have to get ordered properly when stuff gets inserted between them. And so if there's a disconnection now, then yeah, those things have been seen, but now they're going to get some stuff on them. Well, I guess just these guys down here got some stuff on them, but that's going to lock all of these from being pruned for us. But
Yeah,
in
I
your
think
case,
I think I can more aggressively prune, except in the case where the disconnect. I'm not sure.
so in the case of a disconnect,
yeah.
Yeah, and in the case of if this peer is gone and is never actually coming back online, then you can just throw away his data. Okay, so you just throw away these little tags, and then you can prune it. But
And I
you'll
guess
just
if he comes back, I could force. Well, if he comes back with changes, I guess I could force a resync. Like he'll still have the DAG, and I could give him. Well, I don't have the DAG anymore. Yeah, I don't know what to do if he comes back with old changes.
Yeah, someone has to have the DAG if he wants to come back with old changes and perfectly sync. But he can always just start from scratch and be like, I'm going to have to rebase my edits or something.
Right, that's true.
Right, that's what I do on their side. So I give them current snapshot and they can rebase the radius on top of it.
And you can also have a clean disconnection where he says, I'm going away, you can forget me. And then you don't have to leave any trails.
Yeah. I don't know. I guess I need to experiment with rebasing edits. I don't know. For some reason, in my gut, it's like unsettling that this guy maybe made changes a month ago to some version. He's going to come back and rebase all those changes onto like data that's a month newer. Yeah, I don't know
It's
how
definitely
that works out in practice.
like all I can say is that it's a genuine challenge. Like there may be a clever solution, but that's the I don't know of a way to like it seems like you have to keep something in order to connect with that person, some sort of information about what things were like when they were there. Like it seems like in principle there's some, like it makes sense to my brain why you would kind of need something to know which things that they wrote are new even, or
right.
Anyway. I like your idea. I like that idea of a CRDT where you're just going to say we're going to linearize these operations and then we're going to rerun all the operations, and then you can do regular code in there. You can just have code in there, and anything you do, at least it'll be consistent. All the people, they'll see the same thing. Be some
Yeah, he hit surprises pretty quick. So I don't know. We'll see where it goes. Cool. Yeah, thanks for the feedback.
Thanks, Matt. That was really fun. We're being really efficient, guys. So we're only 3 minutes behind time. And I think we have a little buffer. So I think we're totally fine. Any last questions or thoughts for Matt before we move on to Jonathan? All right, then, Jonathan, do you want to lead us through? Or do you want to share the screen?
I think that it would take too long to try and go through it. I just wanted to kind of close the loop. There's been like a whole flurry of intersecting email threads that I've been sending around over the last 2 weeks to everybody here. So I just wanted to try and just close the loop on those and see if anybody has specific feedback or comments that I really haven't handled yet. So so for instance, Matt, you sent me in to
yeah, I think the main
so
comment
one question
was
I had.
Yeah, go ahead.
Go ahead. So one question I had for you, Matt, was in the last meeting, you were telling me about your strategy for doing schema migration. And I wanted to get clear that it's both migrating the local state as well as migrating whatever queue of in-flight operations that need to be sent elsewhere or that are coming in from elsewhere. Is that correct?
Yes, and the way, I guess the cop-out way I've been dealing with that is if two people are in different versions, we're just going to prevent them from communicating. They'll presumably apply the migrations, get to the same version, and then they can send out their changes.
But the changes that they're going to send out are have to be. How do you figure out what changes need to be sent out?
Yeah, so I guess peer A and peer B would keep some notion of the last time they'd communicated. So like A would know, oh, I've seen up to version 5 from peer B. B would say, oh, I know I've seen up to version 2 from peer A. They would do their migration.
So then you get a diff. So this is the same thing as you have to compute a diff, right? From some old to new state here to a bunch of changes that are happening in the new schema.
So I guess I would assume that every change, every change that's happened either from a migration or from events happened after you've been on the new schema would be later database versions. So you would, say, give me all events past this database version, and all those things would be sent back to you, whether they're created by a migration or created after you're on a new schema version.
Right, but okay, so I'm here, I've got this migration, but some changes I've already made haven't gotten out onto somebody else's site. Okay, right. I upgrade my database, but I know that there's these changes that other person hasn't seen, and somehow those have to get converted into changes in the new schema.
Yep.
Right. So that's I just want to make sure there's no way, you haven't figured out some way to get around that.
No, yeah, you would still, you would have to change those to the new schema version before sending them over. Yep.
Right. Okay. All right. Because that's intuitively, it seems like that's kind of just necessary, no matter what you're doing. And that gets hard if what you're doing is an arbitrary SQL migration, right? If it's not just a canned set of change operations, but you're letting them write a program, then you've got to figure out, okay, how do I incrementally execute that program on these changes, right? It's sort of the view maintenance problem you were talking about earlier.
Yeah, and then the other, I mentioned in the email, like, I guess migrations that normalize the data seem easier than migrations that denormalize the data. Just my intuition is like, oh, you're normalizing it, you're creating rows in relations, and you can kind of just like union those. But if you're denormalizing, you're like potentially removing rows and putting them in existing rows, which seems like a harder merge problem to figure out.
Right. So that didn't. So my sort of intuitive understanding is the opposite, right? I thought that when you're normalizing, you're eliminating duplication, and when you're denormalizing, you're duplicating.
Yes, that's true. So you're just inflating your state.
Because what that extract entity thing I'm doing, which is a normalization, is the big problem is deduplication that you need to do in it. Whereas, but
Matt's point is that you're adding records when you're denormalizing, sorry, because when you're denormalizing, you're just expanding existing records with more fields. But when you're normalizing, you're actually adding more records that now have those fields that have been duplicated.
Well, yeah, I'm not sure.
Yeah. So I guess maybe I shouldn't quite call it denormalized, but so in one, I guess we're both right in two different ways, right? Like as Paul said, right, when you're denormalizing, you're adding records to existing records, like you're making some record bigger and contain more data. And when you're normalizing, you're adding kind of new relations, but you're reducing duplication of the data. So I guess it's like, if you're adding relations and adding rows, that seems like an easy merge problem, right? Like it's union these tables. Whereas if you're adding records to an existing row, like you're creating some JSON blob or you're expanding a row with more columns, like that seems like a harder, what do I do when two rows folded into a single row to add data to it?
Well, I think you make a good point, which is that we should look at both. I was looking at normalization, and denormalization has a different complementary set of problems.
Yeah.
And it'd be good to include that. And in fact, duplicating things is problematic too, because, tying into the earlier thing on portals, it's hard to copy. It actually is hard to make copies of things and in collaborative data, right? It's actually pretty tricky how that's going to sort out. Copy here, then the changes have to propagate through and then get copied, and so it's and then what if the copies diverge? It's tricky.
Yeah, right. Because you'd want your copies, you'd want to somehow link your copies, right? So that if you're copying data all over the place for performance, well, it's probably supposed to match the source data and never get out of sync with it.
Yeah.
But how do you control that?
But that's like, I've never seen that, like an actual equality constraint between two rows in any database. The solution to that is always, you just normalize that away so it's not a problem. And that's pretty, so that's a good point that I should add something for denormalization, as that's going to be a complementary set of challenges. Okay, I wanted to clarify that. That was really the main point I wanted to talk with you about. And I'm hoping, I'm recruiting other people to add some more problems here. And if you guys want to get involved, let me know. I mean, now's the time if you want to try and contribute something. Well, we've got a month until final deadline, but if you want to throw something in here, let me know. We're trying to put this together.
Do you have any idea why? Just a random question. Do you have any idea why databases historically haven't supported like incremental view maintenance? Because it seems like, just normalize, but you do need denormalized data for performance. So like ideally if the database just handled incremental materialized views, like this whole problem and argument would go away.
Oh, I mean, it's really tricky. There's a ton of research on this, right? I mean, just, you can search on this, like view maintenance, called the view maintenance problem. I mean, it's a well-researched problem that people have written probably 100 papers about. And it's just really hard to do with any guarantees on how bad, because it can easily get to the point where your incremental maintenance is more expensive than just rerunning the query, right? And so how do you know, when you hit that point? There's people, there's this company called, was it Materialize?
Yeah,
I think it's
Materialize.
Materialize has got some claims to have some really super state-of-the-art stuff. And this is other thing, Beetle DB.
Tiger Beetle.
I think it's Beetle. Tiger Beetle. Yeah. They're also doing something super sophisticated in terms of incremental maintenance. So I think the answer is just it's really advanced stuff, and I don't think anyone's ever gotten to the point of nailing a clear win solution that just always wins enough to get it implemented.
It
so
strikes
people
me
still
as
working on it.
It strikes me as very similar to the problems that we're facing, because you're dealing with incremental changes. Now you're looking at little diffs and patches. I guess we're dealing with a lot of parallel changes. Maybe that's not the same. Okay.
Right. But these guys are dealing with it at scale. They really want to be able to do this on 1 billion rows, and performance is super important. There's also a whole pile of research on incremental computation, which is the problem not in a database, but in code, of just figuring out how to run some code when you mutate the input, how to figure out how to mutate the output, right? It's sort of, the first derivative of code, right? You take the derivative of the code to figure out how to map an input change to an output change. And that's also gets hellishly complicated, especially if it's higher order code, right? You can imagine. So, if you're calling functions, if you're creating functions and so forth. It's just really tricky stuff. But there's a lot you can read about.
Yeah. I started collecting all the papers. At some point, I'll start reading them all and see if I give up or jump on in. We'll see.
A guy Jamie Brandon?
No.
He knows a lot about this stuff, and he was working at Materialize, whatever, and Tiger Beetle, and now he's doing independent research. But he's a guy to maybe make contact with if you want to work on this kind of stuff.
Yeah, if you can send me the info.
I've seen his blog. I think it's this guy, Scattered Thoughts.
Yes. Yeah. Good guy.
I think I've seen this blog before.
Yeah, it looks so familiar. I bet I can do it. I think I might have seen this post before. I'm not sure. Cool. Oh, psychology of programming. Wow.
Cool. Thanks.
Okay. Is that it? That for you, Jonathan?
Yes. Yeah, that's fine.
Cool.
Maybe I'll come back in 2 weeks and I'll have something more solid.
Yeah, and it sounds like this is a really good week to get back to you. So I'll take another look later this week too, and try to put an example together from my mind, and see if that helps. Great. Okay, Jay, do you want to talk to us now about how DNS is backwards?
Sure. Let me see how quickly I can run through this. It'll be a challenge. So basically, the domain name system, the intent is you've got this dance between human-friendly naming and this machine-friendly address. And DNS has sort of taken the name, jaycarpenter.com, and paired that or bound it with this machine thing, and it can be any IP address, IPv4, IPv6, whatever. So the question is, what would happen if you flip that around? And what I assert is if you flip that around, so you've got like a static machine-friendly address, and then you've got various human-friendly address that can be part of that, all sorts of things start to open up, including, I think, squaring Zuko's triangle. So, so I've been working on this, and I've done work, and I've got the beginning of a prototype for, I'll call it a schema that I'm settled with, and I'm hoping to talk to a few people about that. But the initial talk is going to be on this flipping around of the human-friendly, which is subservient to which. Is it human-friendly? The machine is friendly is subservient to the human-friendly, which is DNS. Or if you flip that around, what happens if the human-friendly is subservient to the machine address? So that'll be on Thursday afternoon. But here's the interesting thing for everybody to consider. So, I've been listening to the braid conversation for some time, and I mean, you guys are incredibly smart, and there's a long history of incredibly smart people that have been dealing with this. And it seems like things just sort of start to loop around and get in sort of self-referential. So the question is, what recent fundamental computer science problems have been solved, or Let's look at two. Number one is the Byzantine consensus. And that was solved by somebody who we don't know exactly what their background is, but how did they solve that? What was part of the innovation? Part of the innovation was they added a market mechanism. And all of a sudden, by adding that market mechanism to a bunch of things that have existed before, all of a sudden there was this breakthrough in decentralized consensus. What was the second? Well, the second was in Turing completeness. And again, part of the innovation was adding a market mechanism in order to get a decentralized global computation realm that that solved the Turing complete dilemma of halting. So
You're talking about Ethereum?
I'm talking about Ethereum. So I'm talking about Bitcoin and Ethereum. Both solved fundamental computer science problems that hadn't been solved or nobody could come up with a solution. And
Sorry, I missed solving the halting problem. How was that done?
so this halting problem was solved by adding gas to the computation, to the decentralized computations. So, you know, Vitalik Buterin noticed, hey, well, yes, you can put a computation into this decentralized structure that might be an infinite loop that would, you know, halt things. But if we combine it with gas, then the car runs out of gas and it stops. Does that make sense?
Yeah.
And then you've got to put more value into the gas tank, and then you can run the infinite loop a little longer. So I assert, and I've been looking at decentralized identity for some time, I assert that the missing piece out of viable decentralized identity, and many of the things that I think you're wrestling with here, decentralized state dances with decentralized identity, viable decentralized identity. I think if you had that, then a lot of the things that I'm hearing, at least, there might be a new opening. I think the missing piece is adding a market mechanism. And so you know, again, I'm an amateur at all this stuff. You guys are the computer scientists, but I think there's at least what looks to me like a workable approach to initiate viable decentralized identity, but it's leverages a market mechanism that creates sort of this global fabric of unification. So that's it.
Well, I mean, that sounds true to me, and it also brings up DNS has a market mechanism. And then also the decentralized DNS replacements like Handshake and ENS also have market mechanisms that you can buy a name and squat on it or sell it to someone else. Does that fit with your proposal?
So yes, some of those constructs, you know, fit within this path. The problem with like ENS, and I'm not all that familiar with Handshake, but I think Handshake is also, you know, they are replicating, or they're doing the same thing as DNS, which is you have a single human friendly that can map to multiple machine friendly addresses. And I think, so add the market mechanism and then flip that around, and all of a sudden, a lot of new interesting things open up. Now there's more to it than that. There's other dimensions, but you know, I'm trying to do this in 5 minutes as quickly as I can. And so in any case, those are a couple of the key dimensions of what I'd like to share with a few of you at DWeb Camp. But I am going to do this is DNS Backward session on Thursday afternoon to sort of lay the first breadcrumb.
Great.
Does that make sense?
So we can kind of treat this as a teaser talk.
It's a teaser.
Thursday.
That's right.
That's great.
But yeah, so anyway, I'll go into more detail at DWeb Camp. Michael, with you and Seth and Ty and Matt and Austin and so forth. But I'm pretty excited about it, and I think, you know, and again, I'm an amateur at this, the CRDTs and the OTs and all that stuff, but my intuition is many of the sort of the loops you get into, the self-referential pieces, that can be broken using this market mechanism along with a few other items. And I think it's pretty elegant, pretty simple, but you know, I'm really anxious to hear what you guys think of it.
Great. Well, I feel well teased. That was a clean and clear articulation that made sense and left me open, wanting to know the answer. So,
Very
good job.
cool. Mr. Wright.
Hey, yeah. I've been diligently taking notes on everything I find interesting. One of the reasons I was interested in going to DWeb Camp was trying to pick other people's brains and figure out if anyone's working on a good peer-to-peer database synchronization mechanism. And that's sort of what Braid seems to be doing, but I'm more interested in one of the problems I'm trying to solve is like collecting time series data from multiple sources and having multiple authorities report that and then synchronize that to everyone, to multiple computers. So you can own a copy of this time series database or tabular database or something on your local computer and not have to rely on like an internet connection or a cloud connection. But nonetheless, you get a lot of the benefits of a cloud connection where if you make a change, it can synchronize to everyone's computer. There's a lot of problems involved with that. Like if an authority changes a point in their time series, how do you detect that and propagate that? Or if you detect an error and you need to override it, how do you push that out? If you see that someone else made a change, how do you verify that they have the authority to correct that data? If you need to undo it, how do you, there's a whole bunch of interesting things that come up here that sort of goes beyond just editing documents.
What's a use case for this time series data? So kind of ground me in.
Yeah, like suppose I just want to keep my financial transactions, you know, think like a peer-to-peer version of like QuickBooks or something.
Cool.
And I want to synchronize it between my devices where it still works on my local phone if I have all the data downloaded. And maybe I don't have maybe I don't have a complete database. And if I do want to make a query, it can figure out, oh, I need to go out to the internet and grab this data, or I can go to a local machine on the same network and it knows which computer to go to download that. And part of that would be, you also have to define indexes and things. So, and if you have an index defined and you know you query that index a lot, it would know to keep the data to retrieve rows or records for that index local and prioritize keeping that over other data and things like that. There's been some sorts of databases like this, like I've been a fan of Foundation DB and how it does transactions and how it handles conflicts is quite interesting. It just reruns the transaction if it has to, or it asks it fails the transaction and asks the program to redo it. So that's sort of what I've been interested in. Some of that brushes up against like incremental data. There's one thing that might be of interest here, and I'm going to share this.
Yeah, real quick, Paul and I have both been working on extending SQLite to be essentially do peer-to-peer synchronization. So you might be interested in either one of our
that would be very interesting.
projects.
Yeah, I'll definitely talk about that. So sort of on the topic of like incremental changes, this is a website I've been working on that's just sort of keeps track of different headers in HTTP. An interesting thing here is this table is this table generates RDF data. So if you actually parse this HTML document with an RDFA parser, you'll get back an RDF graph that tells you interesting information about HTTP headers. The more interesting thing about this table is that it's generated from an RDF graph. So what I actually have here is an RDFA template, and I say query the RDF graph that I have, and I have specific commands here that say for each result in this subquery, create a TR element in this table. And this has the interesting property of it guarantees that if you write a template like this, if you parse the output for RDF data with an RDFA parser, that RDF data that you get out from this document it is guaranteed to be in the source database that contains the RDF data, the graph database. And I've also been working on, well, if you make an incremental change to the graph database, you can sort of trace that back and you can see which queries are going to be affected. And then you can figure out which particular elements in the HTML you need to change. So if I add an HTTP header to my graph database, it can see, oh, that impacts this query here. And because it impacts this query, it knows it needs to insert a TR element in this page. The website isn't generated like that right now. It just regenerates the entire output of the document every time. But it seems to me like it should be possible. This is what the RDF data is actually gathered from other documents in the wiki. So it's gathered from like meta tags and A tags and things like that. Here's more RDFA data that it's this is the canonical authority for this header right here. So that's something I've been working on.
That's cool. Yeah, with the incremental materialized views, or
yeah,
two-way mappings between.
The flip side of that is, well, what if you change the query itself and you don't want to regenerate everything? Or what if you change the meaning of one of the RDF tags? How do you handle that? And this is also something I've been looking into for JSON schema, especially like, can you change the schema and also transform the instances of that data from the first instance of the schema into something that means the same thing in the second? Of course, you can't do that in a general because you have to know if the meaning is preserved and things like that. You actually have to define a mapping function. But I think one of the things that I've been looking into is the easiest way to transform a schema is to make sure that it's reverse compatible with the first one. So if you add a field, normally that doesn't implicate breaking reverse compatibility. And when you're talking about databases, if you're talking about renaming a table, that's in the document world, that's the same thing as just creating a new media type. And then you have to define a mapping function that equates the old media type to the new media type. Think about if you want to convert an XML or XHTML document into a text HTML document or something like that, or convert you have to define some sort of equality function and some sort of mapping between them. But if you have, if you define the constraints well enough, and if you define like a forward compatibility mechanism, so that the new type is a superset or a subset of the old type, a superset in its semantics and a subset in the meaning of each byte, this problem becomes a lot easier. And then all you have to do is make sure that you just ignore the data that you want to deprecate or something like that. But actually removing support for fields is usually what the problem is. And I've gotten more into this on how you can detect when this requirement is satisfied or not. In general, whenever you write a software protocol or a document type, you have to make sure that there's large regions of value space that you can use in the future that doesn't error, or that does error if maybe that's what the use in the future intends. So like in HTTP, there's, if you need to make sure that your new feature is incompatible or won't be misunderstood by web browsers or things like that, you can use a new method. And the web servers and web browsers won't understand the new method if you try and talk that new method to it. But if you need to make sure that the new feature is ignored for reverse compatibility reasons, you can use a header, because unknown headers are ignored by default. And that's why I was actually working on the byte-range patch as a media type, because right now the HTTP specification says you can just throw content range into put requests, even if the server doesn't understand it, which would be very problematic. But if the server doesn't understand a new media type, then it'll spit back an error at you and say, I don't understand this. And then the client can gracefully degrade back to some other behavior, like using a put request instead of a patch.
That's cool.
So like, that was my motivation for doing the byte-range patch, which I'm trying to get the APIs working group to take up. So yeah, I think that I'm just covering a bunch of stuff. Also, I forget which talk it was. I mentioned VCDiff. Like I'm trying to see if maybe we can also get a media type registration for VCDiff in the APIs working group. One way, like VCDiff can handle moving content around. Like it can say this byte moved from here to here, and it doesn't do it so directly though. What it's actually doing is VCDiff talks about the old version of the document concatenated right against the new version of the document, and the VCDiff patch itself is a mathematical relationship between different portions of that document, which has the old version and the new version in the same address space. And so if you move data around, what you're saying is copy this first portion from the old document into this address space in the new version, and it'll do this 2 or 3 times so that the data is moved around accordingly. And I think I don't know if this is compatible with protocols like operational transformer things. It strikes me as plausible that you could
I don't
Did
hear.
you lose him?
Yeah, I think we lost him.
Well, here's VCDiff. Looks kind of interesting. Maybe
I'll
this
have to
is,
track Austin down
source and
at
target.
DWeb.
Yeah,
Yeah, more to come at DWeb for sure.
yeah, that was another great teaser. I saw so many connections also, yeah, with Jonathan's schema migrations, and I had thoughts too with the mapping media types together, something I wanted to do. I've done with State Bus or some part of it. And that's very cool. Nice find, Jay. Thanks for connecting us. I think Austin was
Yeah.
the first person to give feedback on the braid specification like 2 or 3 years ago.
I'll take credit. I did a lot of arm twisting in the background there, so, but he showed up and I'm happy that he did. So
Wonderful.
Is he on Twitter or something that I guess I could try to find him at DWeb. I guess it's only 500 people. I'll eventually see him there, right?
yeah, you can find me or him and I'll introduce you. So,
Okay.
yeah. And he is on Twitter. I think
He's probably in the Discord too, right? So I just ping
like
that.
all right, with 3 A's. So anyway.
Cool. We've got one more thing on our agenda, which is test. Okay, that's not that funny. Sorry.
I thought it was funny.
Okay, great. It's time to test, guys. Let's test
I
it.
was,
So,
I was worried that I had written it. I'm pretty sure I didn't. I'm gonna have to. I'm gonna have to go at 7, so I want to throw in my goodbyes early here. Great seeing you all.
Yeah,
Oh,
good to see you. Thanks for everything. Greg, do you run some kind of filter in your Zoom? Are you running some kind of filter because your face looks a little, I don't know, looks processed, but it's not? No filters? Okay.
I think that my face is odd, but not,
naturally beautiful.
but natural.
I just thought
I
you
just
had
think
a
it's
superb makeup artist. So.
I think that I just have this pace. This is my skin. It's a lighting. I don't know. This is not.
I don't know.
I don't do a lot of sunbathing.
I mean,
I think you're a
guess
bot, actually.
there's no
I
wrinkles,
think
so.
See you guys
there's a
later.
lot of evidence here that he's a bot, I think.
Alright.
Good to
Okay,
see
guys.
everyone.
See you guys
meeting,
next
guys.
time.
That was
Bye-bye.
action packed. Learned a lot. Thank you, guys. Bye.